Hi, welcome back to another episode of Algebra in Words, the video series for YouTube. In this episode, we're going to look at an extension of exponent rules by looking at scientific notation. So anyway, let's get started. Before I show you how to solve, and basically scientific notation problems are a matter of converting from either expanded form into scientific notation or vice versa. I'll show you how to do both. Before I show you how to do it, I want to just give a little bit of background on why scientific notation is used. Long story short, scientific notation is used to take a really big number, maybe like this with a lot of zeros, or a really small number, which usually has a lot of zeros in front, and compacts them down into a smaller, more manageable sized number. Now, these types of numbers are very frequently used in the science field. And if you yourself plan to go into the sciences, no matter which field, I highly recommend that you get comfortable with this because it is something that you will use frequently. So now that we have an idea about why it's used, I'm going to show you exactly how to convert an expanded form number, starting with a big number, into scientific notation. And before we start, I just want to let you know, if you prefer to read along with what we're about to go over today, you can read along with it on page 133 of my book, Algebra in Words 2, which you can find on Amazon in the link below. Okay, so let's get started. Now, to set up a number from expanded form into scientific notation, this is what you want to do. You're going to pay attention to, at least for a big number like this, the leftmost non-zero number. In this case, it's 4. So I'm going to write 4 here, and we're going to go from there. The next step is to always put the decimal to the right of that first non-zero number. So that's pretty simple. All right, and then the next step is going to be if there are any more non-zero digits to the right of the front number, you can put them as they're listed behind the decimal. But a little side note on that, I noticed that every book is a little bit different on this, and when you get into a science class, it seems like they'll explain more specifically about how many digits to show after the decimal. Sometimes the question in the book or the test will tell you how many decimals they want how many places they want reported after the decimal, but a lot of times they don't. So when they don't, you kind of have to wing it, and a good rule of thumb is to basically put any of the non-zero numbers that are listed after the front number after the decimal. But sometimes it may specify how many digits it wants your answer or scientific notation. In that case, once it specifies, so for example, suppose it says convert 410 million into scientific notation with 2 digits. Well, the first one would always be the first digit. You need at least that one. And usually you have a second one, but you may or may not. So if hypothetically it said to 3 digits, then what you're going to do is you're always going to look to the third digit and look to see if this number is 5 or greater. If it is, then the number to the left of it will be bumped up by 1. But if this number, the third digit, is not 5 or greater, say it's 4 or less, then you leave the number to the left of it as it is. So since this is 0, a number less than 5, we're going to leave the 1 to the left of it as 1, and I'm going to leave the rest off. But again, sometimes they specify how many digits, and sometimes they don't. If they don't specify how many digits, there's basically no rule at that point. You might want to ask your teacher about that. Alright, so we wrote the first non-zero digit, then the decimal, and then any digits that were after the decimal. Then you write times and 10, and the next and last piece to this is what exponent goes to the power of 10, or above as the power of 10. And the way that you're going to do that is just like this. Take your pencil or your marker and put it where the decimal place is in expanded form. Now remember, in a number like this, even though you may not see the decimal, it's assumed to be at the very end. Or it could be shown somewhere, and if it's shown somewhere, start there. But in this case, it's starting here. So we're going to put our pencil here, and we're going to count one at a time, as many places over until we land right here. So starting on the right, we're going to go to the left. 1, 2, 3, 4, 5, 6, 7, 8. And put the decimal there. Notice that the decimal lands where we have it here, to the right of the first non-zero digit. And since we went over 1, 2, 3, 4, 5, 6, 7, 8 places, we write 8 as the exponent to 10. Okay? So to summarize that, we were converting a large number from expanded form into scientific notation. We wrote the first non-zero digit, then the decimal, and then any digits that came after. Then we wrote times 10, and we determined that the exponent here was the number of places we counted from the decimal over to the right of the first non-zero digit, which in that case was 4. Also, we moved our decimal left. And when we move our decimal left from expanded to scientific, the exponent is going to be positive. You don't have to write the plus, but you need to know that it is positive, and I wrote the plus just so that you can tell the difference between negative. So now let's look at the next one, and it's a smaller number because there's a bunch of digits and zeros in front of the first non-zero digit. So we're going to set it up just like we did the top one. We're going to find the leftmost non-zero digit. That would be 1, and write 1, then decimal, and then the next digit, which would be 8. There's no other digits past the 8, so we don't have to worry about rounding in this digit. Times 10, and now we have to figure out what exponent goes here. Put your pencil where the decimal is, and count the number of places until we get to here. We're going to go to the right. 1, 2, 3, 4. So this becomes negative 4. Okay? We move to the right, and that made this exponent negative. Very important to tell the difference between going right and a negative exponent and moving left as a positive exponent. And that brings us to going in reverse order. So I have a couple problems up here, and let me erase the ones on the left because we're going to figure those out. So now we're going to look at taking something in scientific notation and converting it into expanded form. Okay, now it's a good idea to remember what the exponents are, the relationship of the exponents with the direction that you move the decimal. And the way that I think of it and the way that I best describe it is the exponent are basically instructions on how to convert it back to expanded form. Okay, so let's start with this one. 7.13 times 10 to the negative 5. So what I recommend you do is first pay attention to the exponent. It's negative. Okay? Negative means we're going to convert from scientific into a small number. That should trigger your thought that we're going to be moving the decimal place now to the left. This means to the left. So we're going to put our pencil where the decimal starts, and we're going to move the decimal this many places to the left. This is 5, so we're going to go 1, 2, 3, 4, 5. And then where you land, put a big decimal, fill in all the little gullies with a 0, and also put a 0 to the left of the decimal. Alright? And I'll just rewrite what we have here to the left. 0.0000713. And notice I listed all the digits that were shown originally after the 7 and including after the 7. Okay, now let's pause a second because if you're looking at this one and comparing it to the one above, This one says you move right and make the decimal negative. And that's true, but that's when we're going from expanded to scientific. But when you're going in the opposite direction, then we're going in the opposite direction from here. So in this one, we move the decimal right to get it into scientific for a very small number. But for this one, which is going to be a small number, the negative exponent means move the decimal place to the left when going to expanded. And if that's confusing, it's something that you might consider just memorizing. So let's apply that to the one below now. And if you notice below, this one is 4.005 times 10 to the positive 6. So if the top exponent, which was negative 5, meant move the decimal to the left 5 places, then you should realize that a positive exponent means the opposite. It's going to signify changing this to a big number, zeros afterwards, and we're going to move this decimal to the right this many places. So start here and just move your pencil 6 places to the right. 1, 2, 3, 4, 5, 6. And I'm just going to rewrite that over here so it's a little clearer. So starting with 4.005, and we're going to move it to the right. 1, 2, 3, 4, 5, 6. You can put the decimal there, fill in the empty spaces with zeros, and you're basically done. Alright, so we're done. There's not really much else to say about it, except for you have to pay attention to the sign of the exponent, because that tells you the direction to move the decimal place, and you move it that many decimal places, and then if there's any open spaces, you fill them in with 0. Now before we end the video, I want to make one last comment, which is sometimes people will read the exponent as the number of zeros to put in front of or after the number. But you shouldn't interpret the exponents as the number of zeros. You should interpret them as the number of decimal places. And then if there's empty spaces, fill them in with 0. But the reason why you should not think of the exponent as zeros is because that can be, sometimes it may work coincidentally, but other times it can be deceiving and make your problem wrong. In the case of this, notice we moved our decimal 1, 2, 3, 4, 5, but we put 4 zeros, not including this one because that's to the left of the decimal. But that kind of makes my point that this number does not mean number of zeros. It only means number of decimal places that you move the decimal from original back to expanded form. So that's pretty much all I have for this video. I am going to go over a couple more examples in a later video, as well as on Facebook and Instagram. So anyway, thanks for watching. Please make sure you hit the little bell so that you can be alerted when new videos come out. Also, if you found the video helpful, please share with your friends, and please subscribe, and also leave feedback in the comment section. You can also find links to my other pages and the books in the comment section below. So anyway, thanks for watching, and I'll see you in the next video.